Yeah, it will be fine.
Yeah, true. Because with maths, if you can find one counterexample, then the statement doesn't apply for that particular problem. But the statement still states that if you have the square root of a number, do you see that? Then what's this? Anything under the square root should be positive. So we are saying that if we have okay, let's do this. So if we have the power of x to the power of 1 over b, and we know b is odd, right? Meaning that b is to the power of 1, ne? So it'll be 1 over 1. So then x will be 1 over 1, so which will be x to the power of 1, ne? And then b can also be 7 because 7 is an odd number. So then x is equals to 1 over 7. So then we are saying that x is an element of real number for the domain in such a case.
Yes,
Are
ma'am.
we? So meaning that the seventh root of x, the domain will be x element of real number. The cube root of x, the domain will be x element of real number. And yes, it does make sense. If it's an even number, then the square root of that particular number, or the whatever eventh root of that particular number, the domain should be x greater or equals to 0. Are we all together there now?
Yes, ma'am.
So meaning that if we have the fourth root, okay, now it makes sense. So if we have the fourth root of x, we know that the fourth root of x can be written as what? Can be written as the square root of x to the power of half. Do we agree? So therefore, anything
Yes.
under the square root should be greater or equals to 0. Now, if we have the eighth root of x, do we agree that this can be written as what? This can be
Square root
written
of x
as
over 1 over 4.
the square root of x to the power of 1 over 4. Therefore, under everything under the square root should be greater or equals to 0. So in conclusion, we are saying that if this is a and this is x, and a is even, then the domain is x is greater or equals to 0. I think now we're on the same page.
Mm.
And no, thank you very much for pointing out that. Now, can we move on to the last part? Guys, you said you wanted to be here, but now you are acting as if you're not wanting to be here because you are quiet.
Let's move on to
Okay, functions. One-to-one functions and their inverses. Don't tell me you don't know that. You know it. Objective. At the end of the section, you need to know what a one-to-one function is. You need to find the inverse of a function. You have to find the inverse of a function. Finding the inverse of a function. What are they saying? You have to know what a one-to-one function is, the inverse of a function, finding the inverse of a function, graphing the inverse of a function, application of the inverse of a function. Do you see these applications, guys, are always there? So don't be surprised when you get it in the exam. Now they say the inverse of a function is a rule that acts on an output of the function and produces the corresponding input. Statement makes sense, right? Hmm? So the inverse under does. That's what the and does and does or reverses what the function has done. Not all functions have inverses. Those that have are called one-to-one function, meaning that if you are given something, it has to be a function. Then you can say whether it's a one-to-one function or not. Are we all together there?
Yes.
yes, ma'am.
Thank you. So the inverse
Yes.
is the reverse of the function. That's what they're saying. What is a one-to-one function? Let's compare the function f and g, whose arrows are drawn. Remember this one, we said that for it to be a function, for this part here to be a function, 1 must map to 1. 1 must map to 1. 1 must map to 1, and 1 must map to 1. Do you remember that one?
Yes, ma'am.
Now, they're saying that in this case, when it comes to now checking whether it's an inverse or not, this function f is an inverse because then 1 maps into exactly 1 on the other side. But g is not a one-to-one function because why? There's one term here that maps into this one, and there's one term that maps into this one.
Yes.
And what example can you give there? Which one? Which function represents g? Guys, which function is not a one-to-one function?
G.
Yes, but give an example of a function that is not a one-to-one.
Parabola.
Piecewise
There we
function.
go. It's a parabola. Because a parabola, if you put -2 and 2 in a parabola x squared, you get the same answer. Okay? Oh, where am I? Okay, let's say, note that f never takes on the same value twice. Any two numbers in A have a different image, whereas G takes the same value twice. Both 2 and 3 have the same answers. That's what they're explaining here from the above. Now that if in symbols, G of 2 is equals to G of 3, but f of x1 is not f of x2. Whenever you have two values of x, such that when you substitute them and they don't give you the answer, then we say functions have this. So when functions, so okay, here they're saying whenever you have two values of x which are not equal, if you take them and substitute them into the function like this, right? And the answers are not equal, then we say that the function is one-to-one. Are we all together?
Yes.
Yes.
Thank you.
Yes, all together.
Now, the definition of a one-to-one function, a function with domain A is called one-to-one function if no two elements A have the same image. That is, if f of x is not equals to x2 whenever x1 and x2 are not the same. So if you choose two x values that are not the same, substitute them into a function, and if they give you a different answer, then that is a one-to-one function. As we said, if we can find two values that are not the same, substitute them into the function and find that those two values, the images of those two values are the same, then that's not a one-to-one function.
Yes.
Thank you. So an equivalent way is the other way condition is saying find two values that are the same, you substitute, and they should give you the same answer. Now, there's something called the horizontal line. If a horizontal line intersects the graph of f at more than one point, then the function in figure 2 that are numbers, so meaning that for x, for this x and this x, you get the same value of y. So meaning that this is not a one-to-one function. This is not a one-to-one function because same as a parabola, it's not a one-to-one function. Because for two different values of x, you get the same value of y. Therefore, we have the following geometric method for determining whether a function is one-to-one. So there are two methods. You can use the algebraic method for determining whether a function is one-to-one. Those are the examples in the textbook. Sorry. And also you can use a geometric method. A geometric method is when you draw a graph and then you use the horizontal line test. So the horizontal line test says a function is a one-to-one if and only if horizontal line intersects its graph more than one. What are they saying? A function is a one-to-one if and only if no horizontal line intersects its graph more than once, meaning that the graph must be touched once for a function to be a one-to-one. That's a horizontal line test. Don't confuse it with the vertical line test. What is the vertical line testing? Test. Guys? Hello?
Ma'am, for a one-to-one function, isn't it that when we draw the inverses of like a function and then we try the vertical line test on that one?
No. The vertical line test is the first thing you need to do in life, right? So without the vertical line test, okay, listen to this. Without the vertical line test being true, then you can't talk about horizontal line test. Does it make sense?
Yes.
So meaning that it has to be a function. The vertical line test tests whether whatever you have. Remember, a circle is not a function. Because if I draw a vertical line test like this, it cuts twice. Now, since a circle is not a function, then you can't talk about horizontal line test. Never, don't even dare. Does it make sense?
Yes.
So meaning that if you are given a function like this one, like this, and then you draw a vertical line, and you see that vertical line touches the graph once, then that is a function. That graph is a function. And since that graph is a function, we then go and draw a horizontal line. If the horizontal line touches the graph once, like in this case, is the horizontal line touching the graph once?
No.
No.
Then that
Nope.
function is not a one-to-one function.
Yes.
First step, vertical line. Vertical line tells you whether whatever you are given is a function or not. If it's a function, that's the second step. If it's a function, then you use the horizontal line to say it is a one-to-one or not one-to-one. Is it clear now, guys?
Yeah.
Yes.
Now, is the function one-to-one? Guys, is the function one-to-one?
Yes.
How can you prove it algebraically and how can you prove it numerically? Let's start algebraically. How can you prove it algebraically? Guys?
Substitution.
Yes. You take these two values, you assume these two values are x, are the same, are not the same. So then you say, okay, fine. If I have x1, which is not equals to x2, and I substitute in f of x to get f of x1, if that is not equals to f of x2, right? Then this is a one-to-one function. Is there a value of x that is not the same as the value of x? Is there a value of x1 that is not the same as the value of x2, such that when you substitute into this equation, you get the same answer? Huh?
I'm lost.
Okay. Can you choose a value of x1, which is different to x2? Ne? When you put them in this equation, x squared, do they give the same answer? For example, let's look at parabola. Parabola is like this, right? X squared. We agree, ne?
Yes, ma'am.
If I choose x1, to be equals to -2, and I choose x2 to be equals to -2, +2. x1 in this case is not equals to x2. Do we all agree?
Yes.
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 If I substitute x1, I get 4. If I substitute x2, I get what? -4.
-4.
So meaning that f of x1 is not equals to f of x2. I'm sorry. F of x1 is equals to f of x2 for what? For values of x that are not equals to. Do you see that? For the values of x where x1 is not equals to x2. And since you were able to choose two x values that are different but gave you the same answer, then that is not a one-to-one function. That's what they're saying here. They are saying that if you choose two different values, they should give you two different answers. So in this case, we chose two different values that gave you the same answer, which means that this function is not a one-to-one function.
Ma'am, I have a question.
Yes.
By you saying it should not give us the same answer, it's like getting, let's say you get 9 and -9. You get
Yes.
a +7 and -9. That would be considered as the same answer.
It's the same.
It's the same because what is the square? What is the -9 squared? It's 81. What is
Wow.
+9 squared? It's 81. So then it means that that's not a one-to-one function. In mathematics, if you have a statement and you can go and find one example that disproves that statement, then the whole thing is wrong. Do you see that? So in parabola, we know that there are two values. If I can choose two values, for example, right? 1 and 1, -1, they'll give me 1. -2 and +2, they'll give me the same answer, which is 4. Therefore, that is not a one-to-one function. But for a cube, can you go and choose a value and a value that are not the same? You substitute there and get a different, the same answer.
Okay. No.
Yes, there's no value. So therefore, you can say if x is equals to if x is not equals to, there are no values of x and x2 that will give you f of x is equals to f of x1. Therefore, this function is not a one-to-one function. Does it make sense?
Yes.
Yes, no, guys.
Yes, ma'am.
I need 3 yeses.
Yes, ma'am.
Yes,
Okay.
yes, understand.
Thank you. So there we go. They're saying if x1 is not equals to x2, then x1 to the power of 3 cannot be equals to x2 to the power of 3. Two different numbers can not have the same cube. Therefore, x to the power of 3 is a one-to-one function. That's the solution. Otherwise, you can go and draw the cubic function and use the horizontal line test and say, this is what? This is a cubic function. If you use the horizontal line test, it only touches the graph once. Therefore, it's a one-to-one function. Altogether. So there are two ways. You can do it the algebraic way, or you can do it this is the algebraic way, or you can use a graph and use the horizontal line test.
And ma'am, can I ask?
Mm.
If you say a cubic function is a one-to-one, what happens when you get that cubic function that's like the two parabolas?
But this one is this particular cubic function is a one-to-one function.
Oh, so not all cubic functions are one-to-ones.
No,
Okay.
not all cubic functions are one-to-one, because some of them, they start to bend. Do you see that? Then you have
Yes,
that
ma'am.
cubic function that you're saying. You are proving that this particular one is a one-to-one function. The reason why I said a parabola is a one-to-one function, is not a one-to-one function, regardless of a parabola to being f of x is equals to ax squared plus bx plus c, it will always look like this or like that. And the horizontal will always do this. That's why I say specifically for any parabola. But for this particular cubic function, this is not one-to-one. Okay? Note that the function in example 1 is increasing and is one-to-one. In fact, it can be proved that every increasing function and decreasing function is a what? The one-to-one. The one-to-one. Is it making sense, guys? If you have a straight line and it's, you know that if you draw it like this, it's increasing. Do you see that there's no other changes of the increase or decrease? It's just increasing. This is just decreasing. This is increasing, 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 increasing. So they're saying that all increasing functions or decreasing function are one-to-one. Does it make sense? Oh no, yes or no?
Yes, ma'am.
So once you have increase,
Yes,
increasing, decrease, 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 then that's not a chances that that's not a one-to-one function. It has to only increase or only decrease. Then you say it's a one-to-one function. Now the inverse of a function. Okay. The first thing you prove it's you use a vertical line test to say this is a function. Once it's a function, you can tell whether it's a one-to-one function or not. If it's a one-to-one function, then we can talk about the inverse of a function. Make sense? Yes, no. Hello?
Yes.
Okay.
Yeah.
One-to-one functions are important because they are precisely the functions that possesses inverse function according to the following definition. So now they're saying the definition of an inverse of function, let f be a one-to-one function. Now, they're saying that the domain of f is A and the range of f is B. The inverse, which is not f to the power of -1, but it's written the inverse like this. This is not equals to 1 over f, guys. Don't confuse that. So they're saying that if f has a domain A and the range B, remember the inverse does the reverse, meaning that the inverse has the domain B and the range F, and they can be defined as follows. Are we okay with the definition of an inverse?
Yes.
Danko.
Yes, ma'am.
Don't just say yes because you want me to finish the slides. This definition says that if f takes x to y, then the inverse takes y to x. If f were not a one-to-one function, then the inverse will not be defined. It won't be okay. It won't be unique. Let me not say it won't be defined. It won't be unique, meaning that you can find more than 2 inverses from one function that is not a one-to-one function. That's what they're saying. Do we agree or not? Guys?
Yes, ma'am.
Yes, ma'am.
Does it make sense? They say if a function is not a one-to-one, then you don't have a unique inverse. That's what they're saying. Uniquely defined inverse. Can we make an example?
Yeah, we can make an example.
Please.
Yeah. So what is the example? Because you said yes, we understand. Mm?
What is the
You
question?
can use a straight line.
But a
Yes.
straight line is a one-to-one function. They say if f were not a one-to-one function, then the inverse is not uniquely defined.
Or a parabola.
You can
So
say
if you have yes,
you can say x plus 5 will not give you 1-to-1. Does it make sense?
It will give you 1 to 1. It's an increasing function. The straight line.
Oh,
Eight.
x to the power of 2 plus 5.
Even x to the power of 2. Thank you. F of x is equals to x to the power of 2. When you go find the inverse of this, you'll have plus y is equals to negative square root of x and y is equals to square root of x. Those are two different functions. That's why they're saying you won't find a uniquely defined inverse. Does the statement make sense? If f is not a one-to-one function, meaning that this is not a one-to-one function, therefore their inverses will not be like one inverse, it will be like 2 or 3, depending on your problem. So it won't be unique defined. Does that make sense? Eh? Can I move on? Yes or no?
Yes, ma'am.
Okay.
No.
So did I say no?
Yes.
Why?
Which I do not understand when you say x is equals to minus square root of x and x is equals to, I don't see it on there. You wrote
Okay,
it in the paper.
I'll explain it in the example.
Yes.
But you understand that f of x is not a one-to-one function.
Yes, I understand that.
Okay, then remember this statement that says if f were not a one-to-one function, then the inverse do not have a uniquely defined. Then I'll explain. So now they're telling you that the domain of the inverse is the range of the function. Now the range of the function is the domain of the inverse. Do you see they swap?
Yeah, I see it.
Thank you. Now they say if f of 1 is equals to 5, f of 3 is equals to 7, and f of 8 is equals to negative 10. Answers very quickly. F of negative 5 is equals to what? F of 5 is equals to? Guys.
1.
1.
1.
1.
F of 7.
3.
3.
3,
And f of negative 10.
8.
8.
8.
Thank you. Makes sense, right? Because the inverse is the opposite of the other one. Does it all make sense to all of us?
Yes.
No.
Yes, ma'am.
ma'am.
If this is the x value for the function and this is the y value, for the inverse, this is the y value, the x value, and this is the y value. That's what they're saying. So this is x, this is y. 1 is x, 5 is y. For the inverse, 5 will be x, 1 will be y. It's just the return. So here, when they say the inverse of 5, you just go take this one here. That's what you're doing. That's why we're getting that. Are we all together now?
Yes.
Good do. So then they say figure 7 shows that the inverse reverses the effect of f in this case, meaning that you can see the first one, you have 1, 3, 8. It maps up to 1, maps to 5, 3 to 7, and 8 to negative 10. The inverse will do the other way around and say negative 10 to 8, 7 to 3, and 5 to 1. And don't make a mistake. The inverse for an exponent, it does not mean 1 over f of x. The reciprocal of 1 over f of x is written by, do you see how it's written? So don't be confused in the exam. Do you see how it's written? It's f of x bracket to the power of negative 1. That's 1 over f of x. All in the same boat?
Please write it down before you.
Hey, mine is thinking, man. Can you repeat?
I'm saying that when you have the inverse, this, how, I was surprised why the pen is no longer writing. It's because of this. I didn't lock the meeting. There we go. Let's see. Where's the word document? I just want to see something. They are saying that f this is not equals to 1 over f of x, guys.
Yes.
It's not. So meaning that in the exam, if you see f of x to the power of -1, this is 1 over f of x. And if you see this, that's an inverse.
Mm.
Yeah, bro. Let's continue. Someone is not muted.
Sorry.
So by definition, the inverse function, that is inverse, undoes what f does. If we start with x, apply f, then the inverse will arrive back at x, where we started. Similarly, f undergoes what undoes what the inverse does. In general, any function that reverses the effect of f in this way must be the inverse of f. These observations are expressed precisely as follows. So now this is the inverse function property. They say that if you have an inverse, listen to this. If you have a, can someone read what's this? What's this? What is this? What is this?
Inverse of fx.
Inverse of f
Is
of
that-
x.
am I
F
going-
of X.
Inverse of
The inverse of
F X.
Okay, explain this part then, the inverse function property. Or should I skip it?
It's, ma'am, isn't it what you've been telling us that if
They're
the graph
saying that
is a 1-to-1, then the inverse is what's the word I'm looking for? Then it has an inverse.
Yes, then it has an inverse. But what are they saying here in these two lines?
they're basically saying when it's inverse, the y value is equal to the x value.
When it's inverse.
Is the fx is equals to x.
the function
I
of
know
the
someone
inverse.
is an answer and is keeping quiet. What's going on here?
Is a function of the inverse.
That's a okay. So then, what do you call those things? I'm skipping it, guys.
No, ma'am, please don't.
Ma'am, I think it's a inverse of a fraction.
What is here? Read this. What's going on here?
There's two brackets.
What does that mean?
It means
Ma'am,
Mm.
I'm sorry.
F of x is the inner function of the inverse of x.
Thank you.
Yes.
The inverse function property says that if I take an inverse and I do composition with the function, then I'll get x. Because those two, they cancel each other. Does it make sense now?
yes.
This is a
Yes.
composition. This is a composition of function. They are saying that this reverses what this does. This reverses what this does. So if I take a composition of this and this, that is, if I take the inverse, put it in the function, I'll get x. If I take the function, put it inside its inverse, I'll get what? I'll get x as well. This is called the inverse function property. Are you all together?
Yes, ma'am. Yes.
Guys, these properties indicates that f is the inverse function of f. So this property indicates that f is the inverse function of f. So we say that f and are inverse of each other. So meaning that if I give you two functions and I'm like, which of the following functions are inverse of each other in the exam? You go and take those two functions, do the composition. If they give you x, then those two functions are inverses of each other. You did composition just 2 minutes ago. Finding the inverse of a function. Now let's examine how you compute inverse function. We first observe from the definition of the inverse. Remember we said that the inverse undoes what the function does. If you take y and if you take x and substitute f of x, you get y. For the inverse, if you are taking y, you're substituting in f of x to get x. So if y is equal to f of x, and if we were able to solve this equation for x in terms of y, then we must be able to solve for, we must have x is equals to the inverse of function of y. If we then interchange x and y, we can then find the inverse, which is the desired equation. Now, how do we find the inverse of a one-to-one function? Meaning that a function has to be one-to-one, then you can be able to find the inverse. Then the inverse is uniquely defined. Now, do you see here they're saying, how do you find the inverse of a one-to-one function? Do you see that, guys? Hello?
Yes.
Do you remember the statement that said, if a function is not a one-to-one, then the inverse is not uniquely defined?
Yes.
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 Okay, let's start there. So we know that we know that f of x is equals to x squared. We know that that's not a one-to-one function, right?
Yes,
so we want
it's
to
not.
show that it's not uniquely defined. So they say that write y is f of x is this, so that's step one. So you then write y is equals to x squared. Now they say solve this equation for x in terms of x, if possible. Can we solve this? Let's write this in terms of x. Step two, write this in terms of x. What do I do?
And the inverse, make x, y, and y x.
No, let's not do that first. Solve
Oh.
in terms of x.
Or in terms of x.
Y.
Is what?
X is equals to square root of y.
Okay, let's put x squared this side. We're just changing the position. So y. So then x is equals to?
Square root of y.
No, not square root of y, but x is equals to plus or minus square root of y.
Oh.
Mm.
Do you remember that when you had x is squared is equals to 4, the answer was not x is equals to 2. The answer was x is equals to plus or minus 2, meaning x is equals to 2 or x is equals to negative 2. Because if you take 4 to the other side, then you have the difference of 2 squares.
Yes.
So for example, x squared minus 4, then you have a difference of 2 squared, x minus 2, x plus 2, then you solve for x. So the answer here is x is equals to plus or minus square root of y. And since x is equals to plus or minus square root of y, then the last part they say interchange x and y. So meaning that y will be equals to plus or minus square root of x. So then you have two answers, which is y is equals to negative square root of x and y is equals to the square root of x, which then goes back to the statement that says if a function is not a one-to-one, then it won't have one uniquely defined. Okay, I don't have to say one uniquely, it's the same thing. It won't have a uniquely defined inverse. Are we all together?
Yes.
Yes, ma'am.
Thank you. So here they are saying how to find the inverse of a one-to-one function. So we're assuming that all these functions that we're going to deal with are one-to-one. For example, this is a straight line and we can see it's increasing because this part is positive. So therefore we know that an increasing function or decreasing function is a one-to-one function, meaning that the answer there will get what? Will get one uniquely defined. We'll get a uniquely defined inverse. So they say step one, we have f of x is equals to 3 minus x, 2. Step one, write that as y. So you say y is equals to 3x minus 2. Step two, you solve for x. You go and I know someone is very eager to ask me a question. So y plus 2, I'm coming back to you now. This. So then we can just change position because I want to solve x. So the y plus 2. So divided by 3, divided by 3. Then x is equals to y plus 2 over 3. Now that we've solved for x, then we can interchange x and y. So once we interchange x and y, this will be equals to y over, y is equals to x plus 2 over 3. Therefore, the inverse of f of x is equals to x plus 2 over 3. Ask your question now, or forever hold your peace. And I'll tell you why. Did they teach you like this at school? Yes or no?
Yes.
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 Not all
Yes,
of you
ma'am.
though. Not all of you, because someone said interchange. Why am I interchanging? The
Just
gentleman who
please,
said
why?
interchange.
It's
Yes,
so
I
possible.
was too forward.
You're not forward, my dear. You know why? You can always start with write this and then interchange. Then after that, then you can write the final answer. My only issue is that when you interchange first, and I've seen that in grade 12 learners, they end up not getting the inverse. So always do the interchange at the end. Does it make sense, guys?
So you say we must simplify
Yes.
it first before we interchange.
Mhm.
You must
So for
simplify it
x.
first
Yes,
before we find
because
the inverse.
most people who, yes, because with how we learned was that your y is equals to then so forth, then interchange at the end. Then you make less mistakes. You can interchange. Step 2 can be interchange, but you make less mistakes if you interchange at the end.
Noted.
Yes. So that's what the question. Therefore, the inverse is that. Okay. So, oh, I didn't read this part. Do you see that? They say, so note that step 2 and 3 can be reversed. In other words, you can interchange x and y first, then solve for y. This is how we learned in grade 12 for inverses. That's what they are saying. So you can do this part or you can do the top one, whichever is easier. But for me, I prefer this one because I know the first step, I have to just write y is equals to. The second step, I have to write in terms of x. Then after getting in terms of x, then I interchange. So we got those answers. Rational function. What is a rational function? A rational function is a function defined by a rational expression. In the next example, we find the inverse of a rational function. Don't tell me you don't know what rational function is, right? Because chapter 1 has rational functions. Tell me, what is that? Hello? Guys, what is a rational what is a rational expression? Because they say a rational function is defined by a rational expression.
A rational expression.
Mm.
Oh, isn't it like when you have two polynomials
That are doing what?
that are in the same ratio? I don't know how to explain it, but yes,
Ratio.
Polynomials.
So if you have two polynomials that are doing what? What's a rational number, guys? What is a rational number?
It's a number that terminates in or recurs.
Then isn't a rational number like numbers that can be put into fractions?
Thank you. A rational number is a number that you can put into fraction.
Oh,
So meaning in this case, it's a fraction, right? That's a rational number. Thank you very much. So since a rational number is a number that you can put into fraction, what is a rational expression? There are two polynomials that you do what with them?
Yo. Yes.
Guys, you are saying your H and your chapter 1 has these things. Do you guys even go through chapter 1? Or you flip the coin when answering question. You say, I choose between A and B. Let me flip a coin. And then it says A. Then you remain, I choose B between A and C. Let me flip a coin. And then, guys, did you write the assignment like that?
No.
Because page 36 of it talks about rational expression of chapter 1, the fundamentals. You know, I'm going to ask questions from chapter 1. Eh?
We are editing our submissions today, ma'am.
The thing is not
Assignment 1.
And
Two.
like two
Ma'am.
polynomials
Yes.
that like
Yes, I was saying is when like a rational expression, man. Like I know that the denominator should not be 0, but I don't know how to explain it like proper.
It's a polynomial over a polynomial. That's a rational expression.
So I was right.
You didn't say over. You didn't say polynomial divided by polynomial. You talked about polynomial. Now you are talking about something else.
It's close
So,
enough. Yeah.
So x squared plus 1 over x plus 2, that's the rational expression. X to the power of 3 plus 1. You remember what a polynomial is, isn't it? Don't say you don't.
Yes.
Thank you. Then x plus 1, something like that. That's a rational expression. And with rational expression, if you interchange first, it confuses. Now, in the next example, we find the inverse of a rational function. Let's see. Here's a rational function, guys. So step 1, what do we do?
We must say 1 minus x minus 1 is equal to 0, because then it means that x minus 1 must not actually be, x must not be equal to 1.
We're not finding the domain, we're finding the inverse. Step 1.
It times.
Can I answer?
They
Yes.
solve for
You
x.
swap fx and x.
First, we say y is equals to
Thank you.
2x 3 over.
We say y is equals to 2x plus 3 over x minus 1. Then step 2.
We solve for
Cross multiply.
We solve for x.
in terms of x, yes.
So then we have y, x minus 1 equals to 2x plus 3. I'm assuming that your algebraic skills are good. Right? So you take this one, then you need to go and practice your chapter 1. Then you take y to the other side, so plus y. So then you take x outside, y minus 2 is equals to 3 plus y. Then you say x is equals to 3 plus y over y minus 2. Since you have solved for x, then the last step is to interchange. Then y is equals to 3 plus x over x minus 2. I just like writing it like this, over x minus 2. Do you see that? Go in and interchange first and see if it's easier to, if you don't make a mistake. Your step 2, where you interchange first before you solve for x, for y. You can do that.
It will still give you the same answer.
It will give you the same answer. It will give you the same. If your step 2, you interchange, then solve for y, then it's fine. Me, I like interchanging
So
at the end. Yes.
if you interchange first, does that mean you're losing marks? Or do you have
You're not. You're not. It's just the same thing, just in J. For me, I prefer how I do it. You tell me how you prefer doing it.
I prefer to interchange first, man. It seems easier because once you make a mistake in one of the steps, it's gonna be wrong. You see? So yes, to avoid such.
Yeah, you see, like I always say, people are different. Someone who gets 90, someone can get 90% and they go and sleep and cry the whole night because they didn't get 100. Then I get a 50%. I'm like, ha, a pass is a pass.
Impossible.
Impossible. You see? So that's what I'm saying. It's different. What you might see difficult, it might be easy to me. What you see easy to me, it might be difficult to you. Just like that. As long as we get to the same answer. There's so many ways of killing cat in mathematics. Let's not literally do that, though. Yeah. Oh, so therefore, we forget the therefore. Oh, yeah, but can I move forward? We go.
Yes, ma'am.
Wait.
Hey, the pastor was going to leave you. What's wrong?
Ma'am, is this session recorded?
Don't say that. Don't say that. I don't know. I don't want to even check now because I'll faint if it's not
It's
recorded.
recorded. There's a red button there.
It's not recorded. The session.
It's
Oh.
recorded.
Okay, thank you.
If that thing is red, it's recorded.
Oh, that's good. Because I would have fainted, yeah? I don't want 3,000. How many of you? 3,400 students asking me questions. Okay. Now, and then a next question, regardless the ones that will make me faint. Excluding, not regardless. Hey, Sekgowa is the English. Excluding the ones that will make me faint. No question. Can I move forward?
Yes, ma'am.
Guys, I'm starting the how train. Okay? Vroom, 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 vroom. It's nice when you know the answers. You're like, yeah, you see, you even skip steps and you get to the last part. Graphing the inverse of a function. Let's go there. The principle of interchanging x and y to find the inverse of a function also gives us a method for obtaining the graph of f, the inverse from the graph of f. Now they're saying that if f of a is equals to b, then f of b is equals to a, the inverse. So that's the point AB is on the graph of f, and if and only if the point of BA is on the graph on the inverse. Does it make sense on how we are graphing the inverse from what they just mentioned? Yeah?
Yes, ma'am.
Since you're saying, what do they mean?
I was
For
joking.
me,
I don't understand.
you can't joke like that. What do they mean, guys? They just mean that on the function itself, take the y values, make them the x values, take the x values, make them the y values, and use them to plot the graph of the inverse. That's what they're saying. Are you all on the same page now?
Yes, ma'am.
Uncle.
Yes.
So, okay, I just explained that. I explained that, but we get the point. This from the point by reflecting. So now when we are doing inverse, I was going to show you how to to draw the inverse on a piece of paper, but I can't show you because it's online, because then you have to fold papers. You see?
Can't you fold the screen?
Ish. Okay, let's finish here. Maybe we can do as I described, and then we can try doing it so that you show it. If you are going to show it to your nephew, your niece, your daughter, your son, the kid next door, or anyone you meet around, even at the parties, so that they know the inverse. Not everyone knows how to find it. Now, but we get the point BA from the point AB by reflecting about the line y equals to x. Therefore, in figure 10, we illustrate that. So the graph of the inverse is obtained by reflecting the graph of f in the line y equals to x, meaning that if your function was initially here and the value of this point was AB, Then you reflect about this point. The value of this point is BA. Are we all together? So the y, the value here, the x and the y. Here it becomes the y, the x. You just interchange those values. Come on, let's sketch. Let's sketch the graph, guys. Which method are we using? Which method are we using when we're sketching the graph?
That one of y is equal to.
Intercept zero. The x-intercept.
I don't want to use that one.
Y is equal to the square root of x minus 2.
Yes. Okay, let's use transformation to draw the graph or use the table method to draw the graph. Which one are we using? Which one? You can use. You are all okay with the transformation, with the table method, isn't it, for drawing graphs? We did that. You choose points, but where do we choose the points? Remind me, where do we choose the point according to this function? Where do we start? Can I choose -5?
Depends on the restriction, ma'am.
Thank you. It starts with the domain. Depends on the restriction. We say everything under the square root should be greater or equals to. So the domain says x should be greater or equals to 2, meaning that if you're going to choose x to get f of x, you need to start from 2. Then you go upwards. So then you have to have 2, 3, whatever. Let's say 2, 2, 4. I'm just choosing point 2, 4, 6. If I put 2 here, I get what? I get 0. If I put 4 here, I get 2. If I put 6 here, if I put 4 here, what do I get? Square root of 2. If I put 8 here, if I put 8 here, 6 here, I get 2. Meaning that your graph will look like this. From 0, that's 2 and 0s. This is what? Okay, guys, I don't want to. Let's draw it here. That's 2 and 0. So 2 and 0 is here. So that's 2 and 0. Ne? And then we know, okay, so then that's 4 and square root of 2. Square root of 2 is, we know that it's just above the square root of 1. So it should be somewhere here. And then that's 6 and 2. So 6 and 2. 6 and 2 somewhere here. So the graph will be like this. Do we agree?
You're going through something.
Guys?
Sounds like.
Hello, do we agree?
Yes, ma'am.
So that's
Yes,
using
ma'am.
the table
Yes, ma'am.
method. So we know that this is 2 and 0, isn't it? 2 and 0. This one we know that it's what? It's 4 and square root of 2. And this one we know it's 6 and 2. Right? So they're saying when drawing an inverse, you are reflecting about the line y is equals to x. So you're reflecting about this line here. So let me just redraw the Cartesian properly. So this is y is x. So meaning that you are reflecting this here. So to find the inverse, you change this point. You see this point, it's 2 and 0, right? For the inverse, it will be what? The point?
Will be 0.
0 and 2.
0 and
Thank
2.
you. So we know 0 is here and 2 is somewhere here. I'm not drawing to scale, so it will be 0 and 2. This point will be what?
Square root of 2 and 4.
Thank you. Square root of 2 and 4. Let's say it's here. And this point will be what?
2 and 6.
2 and 6.
2 and 6. So it will be here, somewhere here. So then the graph will be like this. Do you see how to find the inverse? Guys?
Yes.
Do you see how to draw the inverse?
Yes, ma'am.
Okay. Now I want you to use transformation because I taught you transformation. Let's draw using transformation. Where do I start? A. by using transformation, where do I start? Remind me. So A is equals to? Guys, we forgot transformation.
Y is equals to
Y is equals to?
square root of x minus 2.
Transformation. We're not finding the inverse. Transformation, 2 point something. Long time ago. And I'm going to ask it in the exam. We want to draw this equation, this function using transformation. Hello? I'm blocking you guys on what will be in the exam. So remind me of transformation. Where do we start when we're drawing a graph using transformation? Guys, I'm also tired. Let's try. Or should I stop and then you continue? Hmm? Yeah, then let's stop the recording and then everyone will continue the work.
Is it the vertical shifting and horizontal shifting?
Yes, that's transformation.
Oh, and then, so for this, will it be a vertical shift or a horizontal shift?
That's why you need to tell me, but where do you start before you start shifting? I'm giving you next week free of class, so please revise chapter 2. You start with the parent function. Some call it a mother function, which is y is equals to the square root of x. And we know that the y is equals to the square root of x is a function like this. Do you see that? It's a function like that. So now, here it says you move to the right 2 units. So meaning that every point will move to the right by 2 units, all the points. So then this graph will be from here to there. All the points will move by 2 units. So it'll be like this. And for you to draw the reflection, then you have to do what I said. You choose points here and a point here. Here we know it's what? We know it's 2 and 0. Here you choose a point. For example, if I choose 4, I know that if I choose 4 here, I know that that will be 4 square root of 2. If I choose 6 here, and that will be 6 and 2. Then you do what I showed you to find the inverse that was drawn like this. The previous one, not what I'm drawing right now. So make sure you understand how to sketch the graph using transformation. And I told you that, guys, so I can't repeat it. Use the graph to sketch. Okay, we did that. Find the inverse of this function. Can you find the inverse of this function now?
Yes.
Okay, let me just do it. So then you have f of x is equals to x minus 2, right? Now we know the domain of this should be, okay, let me not start even there. So then we have that
Please
y
share your
is equals
screen.
to, my screen is screening. My screen is being shared. Is someone not seeing my screen? How many people are not seeing my screen, guys? Hello?
We see.
We can see
So
the screen.
you can see the screen now.
No. Yes.
Can see.
We can all see, ma'am. I don't know.
Okay, I think maybe the problem might be from your side then.
Oh, yeah.
Okay. Let me explain this part. So then they find the inverse. So the inverse is, we say that we have f of x is equals to the square root of x minus 2. The first step is y equals to the square root of x minus 2. You can interchange first, or you can solve for x first. Me, I like solving for x. So you square both sides. This is y squared. It becomes x minus 2. Then we know that x minus 2 is equals to y squared. So we take 2 to the other side. So this is equals to y squared plus 2. Now that we have solved for x, then we can interchange But then now, this becomes y is equals to, this becomes y is equals to, what's this? X squared plus 2. Can someone say something?
Yes.
What is going on? Because our inverse was like this. And this is a full parabola if you draw it. So what must be the restriction? What must be the restriction?
X should be greater or equal to 0.
Thank you. So meaning we're only focusing for x greater or equals to 0 and not the negative part of x's. Are we all okay in that point? Or someone is just confused on the x greater or equals to 0?
To understand.
Do you all understand?
Yes, ma'am.
Yes.
Right.
Yes, ma'am.
Right.
Okay.
Yes.
Anything. There we go. 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 Application. Come on, let's do this. Application. When working with functions that model real-world situations, we name the variable using the letter that suggests the quantity being modeled. I don't think it's the first time reading us this statement. For instance, we might use T for time, D for distance, V for volume, and so on. When using inverse function, we follow this convention. For example, suppose that the variable r is a function of the number n, then we say that r is equals to f of n, then the inverse is equals to f of r equals to n. So then the inverse defines n as a function of r. This is the last question, guys. This is the last question. If you can solve this one, then I'm giving you a break. If next week. But I've been giving you a break, but I'm giving you another one. Then we start with chapter 3. Are we doing chapter 3? Tell me, yes or no?
Today.
No, I'm asking. Oh, not today. I'll faint, eh? Not today. I was supposed to be doing chapter 3. Okay, let's look at this, guys. And I'm not going to help you here. If you don't answer this in the next 5 minutes, then you'll have to answer it.
Five.
Answer.
Not 5. Okay.
Or we just
But you're
doing,
working as a group.
or we just doing A.
And B and C.
Um,
Mm-hmm.
I think the first one's gonna be fx is equals to 2 times x plus 12.
Is there an X here? Look at the question.
No, the x represents for each additional topping.
But did they say it's X?
No.
Which variable are we using?
N.
Well done. So f of n is equals to, so f of n is equals to 12 plus 2n. Are we all agreeing or someone is lost?
Yeah, I agree.
I'm lost.
Okay, since you're lost, what are they saying? Look at the statement. What are they saying? Yes.
Isn't it 12 plus brackets n minus 1 and then times 2?
Why are you saying n minus 1?
Oh. Ish.
Help me here. They're saying that a local pizza parlor, the daily special is 12 for plain pizza, plain cheese. And most of you, I'm sure you don't eat plain cheese here. So they're telling you that for a pizza, the price, let's say this is the price. They tell you that for each pizza, it's 12 rand. Let's say that. In this case, they use dollars, right? If I add topping, one topping, how much am I going to pay?
2 rand. 2 rand.
2 rand. Let's say for one topping. For 2 toppings, how much am I going to pay?
4 rand.
4.
2 times
2.
2. Do you see that? For 3 toppings, how much am I going to pay? 2 rand for one topping, another topping, another topping. So from this, you can see that this is f of n. The pattern is what? It's 12 plus 2 times the number of toppings. That's why it's that.
Okay.
So now they say find the inverse of f. What does the inverse represent?
The topping of it.
If this is the price, okay, let's find the inverse, guys. Okay, let me go copy it from, yes, the inverse is what?
Y, f prime of y is
Not prime, but to the power, not even to the power of n. Yeah, but the inverse is equals to?
n minus 12 over 2.
So you guys have to go and check this thing. Are we all together?
Yes.
You have to go and check this thing, whether it's right or not. Now, this might be different. They say, okay, before that, find the inverse of a function. What does f of represent? What does the inverse represent, guys?
Number of toppings.
Is the inverse representing number of toppings?
Yes, that are based on the cost.
So if the inverse is representing the number of toppings, then why do we have n there?
Name your question.
Isn't this the price? Guys, this is the price. If you put the number of toppings here, you get the price, isn't it? Now, so this is the price. This is number of toppings. You are right to say now this is the number of toppings, and this will be what? The price. The other way around. Does it make sense?
Yeah.
Yes, no.
Yes. So then the inverse gives the number of toppings for the pizza price. That's what they are saying. But in the textbook, what they did is instead of using instead of using f of n, they use p instead. Right? So that they don't get confused. So then they say the f of the inverse, p, is equals to p minus 12 over 2. So as I said, this is the price, this is the number of topping. The inverse takes, this is the number of topping, this is the price. Now they say if the cost is 22 Huh? Dollars. How many topping does it have?
5.
5.
How did you get that?
You substitute
11.
22.
Thank you. So then you substitute, because you know that this is the number of topping, then you can go and say 5 is equals to, what's this? And because we said what? Oh, this is the price. This is the price, right? Then we say 22 minus 12 over 2, which is then equals to 5. So there will be 5. I mean, why am I putting 5 in here, guys? 22. Maybe because I'm tired. Are we all together there?
Yes.
Yes.
No.
I think that's the last one, because we normally end with applications. That's what we got. Yeah, well, yes. The number of toppings. So they say the function gives the number of toppings for the pizza with price P. Alrighty. And they will explain why they interchanged Y and P. So then, here, then C is what we got, 5 toppings. And that's the end of the session. Guys, these 2 sessions were so long.
Yo, I think it was even longer than our session, ma'am.
Yo, I know. I'm so scared.
And it was
UNISA
beautiful.
should consider giving us more data. This 10
No, my
gig.
soul.